Morning grade 7, welcome to your second lesson on similar triangles. To start this lesson off, I'm going to finish off the problem that Mrs. Sherman did with you. And then I'm just going to do the second part of it so that in case you didn't get it the other day, instead of just providing you with the answer, I thought it would be helpful for you to see how you go through the steps of finding it. So I just took a picture of our textbook so that you have the exact same diagram. And remember, what we're trying to do is we're trying to solve the length of FG. So because these triangles are all within each other, we know that they are similar triangles. So they have similar angles, congruent angles. And then we also know that the sides are going to be proportionate to each other. So what I've done over here is I've basically drawn, obviously not to scale, the big triangle, AGD. And I've labeled what I know. So based on the information in the textbook, I know about each of the sides and what they measure. Then I took out the smaller triangle, AFC, and I decided that I actually want to find what the length of A to F is. So I know what the length of A to G is. The book tells me that. It's 48. So I thought to myself, if I know what A to F is, then I can subtract that from that blue line there, which is 48, to figure out the leftover piece of F to G. So just an explanation as to why I actually want to find what A to F is. So in order to find what A to F is, I'm going to look for corresponding sides. Because remember, your sides always need to be corresponding in order for this to work. So 25 and 32 are corresponding sides. So what I'm going to do is I'm going to set these up as a proportion. So I get 25 to 32 is my proportion. Okay, now it doesn't matter if you did 32 over 25, that's totally fine. The main thing is to be consistent with which number you put on top. So I put 25, which is the smaller number on top from the smaller triangle, which means that I'm trying to solve for x. That means I also need to put x on top. Then the corresponding side to x. So here I'm trying to figure out what x is. It corresponds to 48. So again, it doesn't matter if you did 32 over 25, but that would just mean you would have 48 over x. Then what I'm going to do is I'm going to do cross products. So I get 32x equals 25 times 48. And I already did the math ahead of time, just so our video is not too long. But 25 times 48 is 1200. So I've set up a proportion. Now, just like our algebra unit, you want to get x by itself. So I divide by 32 on both sides, because what you do to one side, you must do to the other. So I get x equals 1200 divided by 32, which happens to be 37.5. Again, if you're going to do the math yourself, number on top goes in the box. So now I have to remember, what was the purpose of finding x? Well, remember, over here, x is really this purple line in my diagram, right? So if I know that that is 47.5 and I know that my blue line is 48, I can subtract the purple from the blue. So what I can do is I can do 48, take away, so the whole entire A to G line, take away the A to F line, line up my decimals, and I get 10.5. for F to G right up here in the top corner. Okay, so basically the math is not hard, but it's understanding what you need to do, where to get it. So like I said on Friday, this is a challenge question. You're not going to come across this type of question in your quizzes or tests, but I just wanted you to see how this information could be applied. So now I just want to do a few more different questions with similar triangles. So here we have some triangles and they are similar. What I want to do is I want to solve for x. I want to figure out what x is. So in order for me to do that, I first need to think about the corresponding sides. Remember, your sides have to match up in order for this to work. So this side matches with this side. These two sides are corresponding. And then finally, these two sides over here are corresponding. Now, of course, we don't really care about the green side because there's no information there, but I just want you to see how every side has a corresponding side. So once again, in order to solve for x, I'm going to set up a proportion because I know that similar triangles are proportionate. So I'm going to do, I want to find x, and x's corresponding side is 8. So because they were both highlighted in blue, they both need to be on the blue section together. That's really important. Proportions do not work if you don't line up the corresponding sides. Then I'm going to do the purple, and I have 5 and 7.5. Now, the important thing is to make sure that if I decided to put all the information from this big triangle on the top, which I did because I put X on top, then I also need to make sure that my purple number is on top. Okay? So I get 7.5 over 5. So another way to think about it is that my information from one triangle, let's do colors again just so you can see. Let's say I call this triangle yellow, okay? And then we'll do triangle orange. Now there's a lot of colors going on. But triangle yellow, which I have over here, X and 7.5 come from triangle yellow. And then I have 8 and 5 come from triangle orange. So corresponding lines go together in the same section. And then the information from the triangles you either need to pick the bottom or the top. Okay? So now I just go on to cross products. So I do x times 5, which gives me 5x, equals 7.5 times 8. If I want, I can do 7.5 times 8 on the side. Remember, when you're multiplying with decimals, you ignore the decimal for now. And then I get 600. But because I moved it out to ignore it, I move it back in. So I get 5x equals 60. I want to get x by itself. So I divide by, whoops, don't divide by x, that's not helpful. I divide by 5 on each side, which you do to one side, you do to the other. My 5's cancel out, and then I get 60 divided by 5, which gives me 12. So if I go back to my super messy diagram over here with all the colors, I put on the wrong side, we get that x is 12. Now, always good to think and make sure it makes sense, right? It does make sense that x is 12. If I compare it to the other triangle over here, if I ended up with x being like a really tiny number and it was smaller than my 8 centimeters over here, that would be a problem. All right, let's do another one for practice. So this one, we're actually given all of the sides, and what we want to do is now check if they were similar. On the other problem, we were told that they were similar. This one, we want to check, are they actually similar? So our first steps still apply. Let's find corresponding sides. So the one I always look for first is the longest side. I can see that it's right across from that right angle there. So 28 is the longest side, and then 20 is the longest side, because I usually find that the easiest one to find. Then I usually try and spin it in my head to see what else connects. And I can spin it in my head, and I think 15 and 21 are corresponding. And then finally, 10 and 14 are corresponding. Okay, so now I'm checking, are these actually similar triangles? Are they proportionate to each other? So I'm going to start with the orange lines, and I'm going to I have the proportion of 20 over 28. So I grabbed this is triangle 2 and this is triangle 1. So I put triangle 2 stuff on top. 20 over 28, and I want to check, is that proportionate to, let's check 10 over 14. Again, I'm matching up those blue lines, but because my 20 came from number 2 and it's on top, my 10 also needs to be on top. So then I get 10 over 14. Now I can do some cross products, and I get 280 equals 280. So because they are equal, I know that those lines are proportionate to each other. So I figured out my orange line and my blue line are proportionate, but I also need to think about that yellow line just to be sure and see if yellow is also proportionate. So I'm going to do 15 over 21, and I'm going to compare it to the blue line. 15 over 21 equals 10 over 14. So once again, I do cross products. 21 times 10 is 210. And then 15 times 14. Now grade 7, don't be tempted to just simply write down 210 right here because you're like, well, it must work out. Make sure you always do the math to make sure it actually does work out because you don't want just to assume. So we're going to multiply. 4 times 5 is 20. 1 times 4 is 4 plus 2 is 60. Place a 0. And then I get this. I add it up and I do indeed get 210. So it doesn't take you long to do that extra step. So because all of these proportions equal each other, I know that all my lines are proportionate to each other, so therefore I do indeed have similar triangles. All right, let's do another one where we have to solve for the side. So here we need to solve for x. So once again, start by finding your corresponding lines. So this is my biggest one. I always like to do that one first. This one over here I can just picture flipping on its side, and I should be able to see that 15 corresponds to 30, and then finally line x corresponds to 36. So I want to solve for x, so I'm going to put it on top. X is already highlighted as yellow, so I'm going to do x over 36 because they correspond. And then I'm going to do, well, I can't do blue because I don't have enough information. I'm going to do purple. Notice again, because my x is on top and it's from this triangle, I need to put 15 on top. So I get 15 over 30. Then I can do some cross products. So I get 30x equals 36 times 15. And 36 times 15 actually equals 540. I'm going to say what's happening to x. It's being multiplied by 30, so I do the opposite and I divide by 30. I get x all by itself, and I actually get that x equals 18. Now another way to think about it, just to double check your work, something that I noticed about right over here is 15/30 could actually be simplified to 1/2. It's weird too. So if I look over here and I put 18 over 36, I should also be able to recognize that that can simplify to 1/2. So I know that I got the right answer. Okay, let's do one more. This is again more of a challenge or application one, but I thought it was good to go over it with you. So here I want to solve for x, but I have two triangles within each other. So what I can do if I want is I can first deal with that small triangle, which is triangle y, a, and b. And I know from y to a, it's 17, and from y to b, it's 16. Now I have this big triangle. So really all I'm doing, grade 7, is I'm separating it out. I have the big triangle y, h, and v. And I want to solve what is y to h. But remember, for me to solve a similar triangle, I need another piece of information. So if you notice over here, these two are corresponding, 17 and x, so that's helpful. But then I don't know what's corresponding to YB. I know it's corresponding to YV, but what actually is YV? If I go back to my original diagram, I can see that YB is 16 degrees and BV, not degrees, 16, let's say centimeters, and BV is 22 centimeters. So I should be able to logically think that if I added those together, I would get YV. So then I end up with 38. So now we're really back to a problem that we did before. The only thing was that you had to separate out these triangles and do some addition. So now I can do my regular setup of solving for x. So let's say I want to put x on the bottom this time. I'm going to do 17 over x equals 16 over 38. Once again, notice x and 38 come from the same triangle. They are both on the bottom. So information from specific triangles need to be on the same level. Then we do cross products. So I get 16x, equals 646. I'm going to divide by 16 on both sides. So let's say, so then I would end up with x equals, now I'm going to do some long division, number on the top goes in the box. So how many times does 16 fit into 64? Well, I think 16 times 2 is 32, and times 2 of that is 64, so it fits in 4 times. Bring down the 6, does not fit. Place a decimal, add a 0, bring it down. 16 fits into 63 times. 3 times 16 is 3 times 10 is 30. 3 times 6 is 18, so I get 48. I think I'm going to run out of room. Bring it down. I'm going to run out of room, but that's okay. So then I think 16 fits into 120. I'm going to guess that it fits in 7 times. So then I think 16 times 7. I'm going to keep, like, you could keep going, but I'll just tell you the answer. I just want you to see how to do that. And I get 40.375. So it's a decimal. Doesn't mean it's wrong, because it does stop. Remember, if you have a decimal that goes on for forever and forever and forever, it probably is wrong. But in this case, because it does stop, we can assume it is the correct answer. Also, if I look at it, it makes a lot of sense. If I think about over here, I have 16, and then 17 is just a little bit bigger than 16. Over here, I have 38, and then 40 is just a little bit bigger than that. Okay, so that's your introduction to actually a review of similar triangles with just a few more questions. For your assignment today, I have posted a worksheet for you to do. If you want to print it, you can, but you don't need to. You can just write the answers in your notebook. You're going to notice with the triangles that you are working with. So let's do a triangle for a second. So there you have one, then you have another, and then another one. Make sure that when you are solving for things, that you notice that most triangles each have a variable you need to solve for. So don't just solve for one of them. In order to solve the entire question that you have to do, you need to solve both variables. So just make sure you work carefully through that. Also notice that you might have to pay careful attention to which ones are corresponding if they are tilted or angled in any way. And then feel free to give me a call or chat with me if you have any questions. I hope you have a great day on your beginning of your week 5.